Hi everyone, this is a video from Module 9, group work, on how to use the TI calculator to do inference for two proportions. I'm going to go through how to do the calculations on page 174 and 176. You'll still have to make sure you work through setting up the hypotheses and explaining the data collection parts. Question 1 on page 174 tells us about registered voters in two different groups. The first group is registered voters who were sent reminders about voting, and the second group had no registration reminders sent. And the county clerk is claiming that the proportion of people who registered to vote was significantly larger in the first group who received the reminders. So because they're telling us that's the first group, we're going to put that in for our first proportion. So we go to the Stat button, and then we're going to arrow over to Tests. Since we're comparing two proportions, this is choice 6, a two-proportion z-test that we're going to go through. So we press Enter. And then for each of the proportions, we're entering x1 and n1, or x1 and n2, where x is the part, what's going to go in the numerator, and then n is the total in the denominator. So the different groups are different sizes. That's why our N1 and N2 are going to be different values. So for the first group, there were 394 people who registered to vote out of 703 potential voters in that first group. So that's the group that received reminders. Group 2 has 328 people who registered to vote out of 697 who were in the second group, and this is the group that did not receive reminders. The claim of the county clerk is that the proportion of people who registered to vote was significantly larger in the first group. So when we come down here, we want to state our hypotheses. So our hypothesis is that the first group, proportion 1, is greater than proportion 2. So we come over here and we highlight that third choice. So what this is saying is the P1 over here is greater than P2, the second proportion. When we scroll down, we have a choice between calculator and draw. If we choose draw, we get a picture of the normal distribution, and then our z-score is shaded. It's really far out here, so you can't quite see the shading. And it's telling us our p-value is 4e negative 4. So our p-value is not just 4. The e negative 4 tells us in scientific notation that this is 0.0004. So the e negative 4 tells us move the decimal point 4 places to the left. If we go back in this stat and go back to the same test, so back down to choice 6, if we choose calculate, we get the calculations showing more than a couple decimal places. I think we get 9 decimal places, but we don't get a picture of the graph. But here, this gives us more information. So when you're looking for the z-score and the p-value, probably the more accurate answer is going to come from choosing calculate, but if you want to see a visualization of the normal distribution, you can also choose draw. All right, so here we have the z-score, which is more than 2 standard deviations, so we know that there's going to be a statistically significant difference, right? This is 3.36 standard deviations outside from the mean or from the proportion. Our p-value, our probability that there's no difference, is 3.8396 e negative 4. So this would be 0.000389. When we click draw, they had rounded this up to a 4. So for accurate answers, it's better to go to calculate so you can write your answer to 4 decimal places. All right. And it's okay to leave your answer in scientific notation if you want to say e negative 4, as long as you remember that means it's a really small number. Otherwise, you can put in the decimal places. The P1 hat and P2 hat sample proportions should match your calculations from step 2. And then if we scroll down, we see it's just telling us the sample size values N1 and N2 for the two proportions. Okay, let's go look at the problem 3 on page 176. I'm going to go back to stat. Again, this is two proportions. They're asking about the difference between men and women for marrying a person from a lower social class. And so we're going to choose the same calculator test, choice 6. And now our proportions, instead of being registered voters, are going to be men and women. So I'm going to clear out my values from before. And I'll make the men the first group since they come first in the word problem. So there are 91 men who said yes out of 149 men total. And then I'll make the women the second group. As long as you remember what's group 1 and group 2, it doesn't really matter how you do your setup. But no, if you define group 1 and group 2 differently than a classmate, you might have your proportions going the different ways when you set up your hypotheses. So just make sure you remember when you choose your inequality, which is P1 and which is P2. Okay, so women are 117 out of 236 said that they would marry someone of a lower social class. And then here the hypothesis is telling us different proportions. So we know that we're going to choose a not equal to proportion. And then I'm going to go ahead and go to calculate. And we see here our z-score is 2.2, so it's a little bit above 2 standard deviations. And that matches our p-value. Our p-value is 0.027, so this is a small p-value, less than 0.05. And so the small p-value tells us there's going to be a statistically significant difference. And again, here's P1 hat and P2 hat to check your calculations from step 2. And then you can scroll down and check N1 and N2 should agree with your calculations from the problem. You could ignore the P hat. That's them averaging the men and women relationship. It's a weighted average, so that would be like if they put everybody in the same pool.